Alright, here we are looking at this power source. I hot wired it to the circuit board. It's like an experiment with different capacitors. The original capacitor, which is a 680 microfarad, is not available anywhere, so it's a really strange one. So I decided to use what run capacitors I have, and this is purely experimental. The values, why in the hell would Luzbot TAS 3 run a 200 volt working voltage, 200 working voltage capacitor when there's a switch on the side of this thing that basically you can switch it to 230 volts AC. So it doesn't take a rocket scientist to figure that out, that you're going to basically compromise the capacitors, not rated for that much voltage. So therefore they blew, both of them, 2 days ago. So went ahead, put in some 330 volt. I had these in new old stock. They're not quite, they're about half the amount of rated capacitance. Being they go up to about 324 microfarads. Being that I have lower voltage, I got measured 256 volts AC here, single phase, so I'll probably be more closer to about 300 microfarads. So anyway, enough said. Let's see what happens here. Turn this on. This fan here is thermally protected. Surprisingly, it didn't really turn on very early. Well, let's see what happens here. Hopefully it won't hurt anything. If I move this table, you'll see that the display will light up a little bit just from back inf on the DC motors. So here we go. And hey, looks like we got life. At least the circuit board's running. Now, the key is, let me prepare this thing. It says it's ready. Prepare. Let's go ahead and preheat it for ABS. See what happens. And if we get an increase in temperature, we know we're good. And look at that, we're getting an increase. 37. If it goes over 50, we know we're good. Well, we gotta get up there to 235 Celsius, over 90 Celsius. And so far, so good. I'm really surprised that my experimental capacitor bank is doing the trick. Let's go over here now and see if there's any heat on the wires. Surely don't want to touch these terminals. They'll wake you up like a stun gun. But I'm sending about 200 and I should measure the voltage on these and see what I have. Probably, I'm guessing 256 volts. So fantastic. I'm gonna blow this out and blow all the debris and dirt and dust that got in there. Man, that was nasty. Residual from last time. It let the smoke out of itself pretty badly. So it looks good. I've got 168, 170 Celsius over 61. We're definitely approaching where I need to be. You know what I forgot to do though? I need to add tape to this glass surface because it just will not stick to this. I could try the glue stick method, but not sure I really trust it, frankly. I increased the size of the part to 169 millimeters on the internal. So I'm not sure if that's really going to stick very well. So really the best thing I've noticed is using, it was an orange tape, masking tape that I had. I suppose I could try a print run and see what it does. Anyhow, I'm absolutely blown away that my first time fix worked. I guess my time at DeVry Institute of Technology has enabled me to try things like this with a good guesstimate of values. They're I believe those are in series circuit. It could be a parallel series circuit actually, because I measured the nodal resistances on the circuit board, and only a couple nodes did actually correspond as though they were in series parallel. So it's kind of a complicated circuit in there. Hopefully this is still good, the thermal fan. We're going to find out here shortly. Still spins. Yeah. Can't get near it. Alright, let me get my face in there. Alright, enough. Maybe I'll throw some tape down just for the hell of it. Oddly, it would stick to this somewhat glossy surface of the tape, which is really surprising. Alright, looks like we are there. Look at that. 236 over approaching 90 on the table. So it is ready to roll. And I've got a highly modified print nozzle here. I'm running a 3mm filament from Matter Hackers, and I run a 2.6mm drilled out stainless steel nozzle that I custom make. I used to sell them on eBay. Then people copied it. That's fine. The sincerest form of flattery is mimicry. Alright, well, I think I'm going to throw some tape down on here and just see what it'll do. Let me set this camera down here. It's going to be a long shoot. Again. There's no way for me to hold this. Oh, that'll work. Just set it right here. Okay. That's hot. Really don't want to put too much of this down. I think I will. Oh, it just tore on me. Unbelievable. Yeah, that'll work. Be careful with this stuff. Really is the best method to get adherence to the table. Oops. A little bit of a wrinkle there. No. Yeah, it's definitely hot. Boy, let me tell you. Good. Well, that's good. I put a enhanced thermistor in the nozzle heating element. This does not have to be perfect. The main thing is not to have a big ripple or a step. And yeah, we'll hit go here shortly. Well, that isn't going to be perfect, but the part does not need to be perfect anyhow. No, it'll be very close. It'll be within a couple millimeters. Alright, now that'll give me lots better adherence. Why it sticks to this, I don't know. Well, let's go ahead and hit print from SD. long list of parts here. And this is becoming ridiculously long. Let's get it done here. See what happens. If I can get to it. There's that grinder head nut. There it is. Alright, so we got the motor mount G-code ready. See if it'll accept it. See if the computer can see my selection. It's thinking about it. Oh, shoot. Okay. Alright. I don't think it took it. This is one of the first TAS Luzbot 3D printers that came out. This is definitely not the quickest processor. Alright, let me just let it sit there for a little bit. We'll get it going. And there. Gotta give it a real good definite push. And I'm just gonna let it do its thing. That is hot. Alright. Very long video, sorry for that. But you can feel these buzzing a little bit. Oh good, there's airflow on the fan and it's just turned off. Good. Happy to confirm that. I actually propped this up. It was a manufacturer's flaw, design failure not to have extra legs on this, because really it needs to have an elevated platform so that the air can flow through here more. The bottom, you don't want to plug that off. You want to get these power sources up off the flat surfaces and elevate it like such. Now I can run this with full confidence. I've got heavy duty motor start capacitors, 330 volt rated. These are 270 to 324 microfarad Mars, jarred Mars, heavy duty start capacitors that will much improve the functionality of this 3D printer. And I'm going to cut here about 13 minutes, getting too long. We're just waiting for one little temperature jump here, 1 degree jump on the bed. If I can get this in place. I don't think it homed. It will home automatically. Come on. Getting a little long here on the video. Well, it's hanging in there though. I'll tell you what, it is really... I gotta turn off this big evaporative cooler that I have in here. Don't want to breathe these fumes either. Come on, just 1 degree. That's all we need. There it is. Now, come on now. Proceed. Definitely boring. And it's looking for something here. I don't know what, but it's taking its sweet time. It's got a lot of code in there. Come on. Still trying to heat the bed. I don't know why. It should be, it's right there. Where it's supposed to be. This thing's working fantastic. Couldn't be happier with the functionality here. Now we're just going to see how the rest of this stuff works. It should kick itself into gear here. Come on, table. Get the head and table moving here. I don't think anything else on the power source is compromised. There we go. Well, that had me a little concerned there for a moment. And I hope that it doesn't knock my power source off. Holy cow, that was close, folks. Wow, it does clear. Okay, I gotta watch out for that. That's not good. So, you know what? I need to jump this over a little bit. I'll do that. Let's push this over. Wow, that was too close for comfort. Alright. Almost knocked the whole thing over. So look at that. It is working. My capacitor, external capacitor fix did the trick. And we're getting, this is very old filament, so it might snap on me a couple times. Actually, having some moisture in the shop is good with the evaporative cooler, as it keeps the filament a little more pliable without snapping. And let's see if that tape will not jump up. Let's hope it gets over the edge. I've got a 0.6 first layer height setting that I run with my customized. Oh, that's not good. Wonder why I didn't complete the circle. That was, I think it tried to. It just didn't come out right the first. It's alright. This is just the bond layer, the very first layer that goes down. It's just a kind of a test bond preparation. So it will actually smooth itself out. I put a special coating on the exterior portion of the nozzle, print nozzle, which keeps it from sticking. And it just went right up over top of that little pothole or ridge, speed bump. And so what you can do is just take a hot putty knife while it's still hot and just try to push it down a little bit. That's fine. So let's go around back, move that darn power source. Nudge. Nudge. And nudge. One. Get some more length here. There. All right. That'll work. Don't want to get too close to these guys. They are charged. And keep the space blanket off of it. That would help. And we've got adequate clearance here. I'm going to leave it like that. I don't really think it's a problem. Okay. My line voltage coming in is a bit high today due to the solar system. It's about 256 volts AC, single phase. So it looks like we got a really good start here on this very first layer. Except for that, that's not good. Getting a little gooey. Want to really put something. Made a big mess right there. Not sure I'm gonna let this go. Well, one nice thing about this is that that nozzle will just run right over that stuff that's stood up and flatten itself out. Alright, this is CT with CT Machinery Systems. Thank you for your interest. And this is a successful fix on the Luzbot TAS3 power source using external capacitors off of the circuit board. And then I elevated this to a proper, better, more breathable configuration. And as we can see, this is working brilliantly. Over and out. Take care. See you next time.